The views expressed on Science for the People are not necessarily the views of this station, its affiliates, sponsors, or advertisers.
This week on Science for the People, we are going to talk about the buzz around Dr. Justin Schmidt and his sting pain index, how the public perceives insects and the people who study them, and why Dr. Schmidt interacts with the media to vouch for an especially unpopular group of insects, the stinging kind.
Hello listeners, this is Rochelle Saunders. Just before Anika gets started, I wanted to send out a very special thank you to all our listeners. We've been putting this little podcast out into the void since 2009, and here we are, almost 7 years later. Still on the air, still in your earbuds, still finding new topics to discuss, new fascinating science books to read, and more smart, thoughtful people to talk to. We started all those years ago by getting just a few dozen downloads for each episode. These days, we get over 10,000 downloads every week. 10,000. And with all the other podcasts out there to choose from, pro podcasts with budgets and business cards and advertising, we are thankful to everyone who continues to tune in on community radio and who downloads and listens to this little volunteer-run show. If you listen every week, that's 52 hours a year our voices are in your ears. And if you've been with us since the beginning, that's over 350 hours of your time and attention that you've given to us, to our guests, and to thinking about how science impacts our lives more complexly. So thanks. Thanks for sticking with us. As long as we can keep the lights on, we'll keep finding scientists, scholars, journalists, doctors, social activists, and other experts to talk to about things and ideas that maybe don't get talked about in many other places or on other podcasts. And when it comes to keeping the lights on, we here of the Science for the People team would like to give a very special shout out to all the people subscribed to our Patreon who help us keep those lights on. Over this last year, you have gone above and beyond for us and made it possible for us to expand our team and bring on new hosts, like Anika Hazra, who you'll hear from shortly, and get them up and running with equipment without wondering how we're going to pay for new mics or new software licenses. In the spirit of the season, we'd like to thank the following people for their support on Patreon this year. It means a lot, and we hope you'll continue to support us. Thanks to Alexander, Alfonso, Amy, Andreas, Andrew, Ash, Ashley, Barry, Bethany, Brenna, Brento, Brian, Buddha, Burkhart, Buzz, Charles, Courtney, Corey, Dale, Dan, Daniel C., Daniel L., David M., another David M., Dennis, Elizabeth, Eric, Philip, Frank, George, Gerald, Gurik, Harry, Jason, Javier, Jeff, Jennifer, Jesse, Johan, Jonathan, Joseph, Julie B., Julie J., Kate, Kitty Mayhem, Know Thyself, Leslie, Marion, Michael K., Michael L., Megan, Melanie, Nicole, Pamela, Patrick, Paul, Philip, Pierre, Polydamas, Rochelle T., Renata, Ron, Roy, Ryan, Selena, Scott, Secular Women, Sharon, Stefan, Stephen, Steve, Susan, Timothy, Tina, Tom, Tony, Uschi, Wiley, and Zach. And we'd also like to thank those who have donated via PayPal this year. Your donations are just as appreciated and just as important to keeping us going. Thanks to Anna, Barry, Chad, Diane, Herbert, Ian, Kathleen, Ken, Richard, Sean, Stefan, and Stuart. and also to all anonymous donors who donated to us via PayPal and Patreon. You too have been instrumental to keeping us on the air this year, and we thank you. If you want to join our list of amazing listener supporters that give us warm fuzzies, you can check out our Patreon page at patreon.com/scienceforthepeople. You can support us with recurring monthly donations of as little as $1, and all those $1 donations really do make a big difference. So if you've got a little room in your annual donation budget next year to support a little podcast determined to stay advertising free, consider subscribing to us on Patreon. In return, we regularly post extra conversations and questions with guests that didn't make the final edit. Sometimes these are short, 5 or 10 minutes, but every once in a while we have so much on the cutting room floor that the extra is almost as long as the original episode. If you prefer one-time donations, you can use our PayPal donate option on our website, which you can find at scienceforthepeople.ca/donate. And since it's that time when people are figuring out what their next year's charitable giving strategy is, stay tuned at the end of the show after the interview to hear a few suggestions of organizations that work hard to keep science a valuable part of the conversation. Thanks very much. Now, on with the show.
Welcome to Science for the People. I'm Anika Hazra. With me is Dr. Justin Schmidt, a research biologist at Southwestern Biological Institute and an adjunct faculty member of the Department of Entomology at the University of Arizona. Dr. Schmidt, welcome to Science for the People.
It's my pleasure.
So you wrote a book that was published earlier this year that is both educational and autobiographical called The Sting of the Wild. And a very important component of the book that's garnered you a lot of media attention, especially in the last year, is the complete Schmidt Sting Pain Index. Can you explain what this index is and why you decided to create it?
Yeah, the Sting Pain Index or pain scale was something I came up with in the 1970s. And actually, its origin, the idea came from Ron Melzik in Montreal. He had the original pain scale that's still being used today with 10 points, 1 to 10 for people who have chronic, pain in hospitals, medical things. And I was trying to find a way to quantify pain of stinging insects because I had some theories that insects sting pain related to their ability to defend themselves, and the ability to defend themselves enabled them to become social and live in big colonies like honeybees and yellow jackets and, wasps of that sort. And without being able to make pain, they wouldn't be able to defend themselves against bears and raccoons and, things that wanted to eat them. So that was where I was coming from. And I needed a way to measure and mathematically be able to analyze the different pains. And so that's where the idea of a pain scale, except I couldn't make 10. I'm not good enough to distinguish the difference between, say, a 7 and an 8. But I could distinguish between, a 1 and a 2 or a 2 and a 3 or a 3 and a 4. So we basically had four different elements in there, 4 different numbers. And it was really a tool just to solve a problem that I'd run into.
Okay. Why did you think it was necessary to have an index of the level of pain incurred when stung by different insects?
The pain was actually relevant for their lifestyles. You can say, well, it's kind of relevant to ours that, we don't like going on a picnic when we're being buzzed by a whole bunch of yellow jackets that are eating our sandwich and getting in our soft drinks and, all those things. Maybe they're telling us we should be eating less sugar and let them have it. I don't know. In order to be able to determine what good it was to them, I had to be able to relate it to a defensive value. In other words, if they only have a sting of a 1, then they're not going to deter very much from attacking and deciding that they're dinner. Whereas if they have a 2, that's a much better deterrence.
Okay, so you mentioned that you have only 4 levels in your Sting Pain Index. And did you figure out the scale system just subjectively? Or did you say that you could only go up to 4 levels because that's just about as much as you could handle in terms of measuring or quantifying pain?
I went to just 4 different levels because I really felt that there were so many variables between, getting stung and what you rated. For example, if you get stung on the back of your hand or your wrist or your arm, it's got one kind of insect, the same amount of venom in the palm of your hand or on your nose. Wow, it's a whole lot more. And so I wasn't, willing to say, well, I'm going to go and intentionally get stung, X number of times on some regular place, say the back of my hand. I wasn't really interested in doing that. I was just interested in getting kind of an average value of what it would hurt. And so that I could not really distinguish, some bees, for example, I've been stung on the inner part of my thigh, which is kind of tender skin down there, which, I never thought about that. One just flew up my shorts one day. Ouch. No, it didn't hit where people's minds are going. Stay away from that. It just stung my leg. And anyway, that thing really hurt. So that would have been, like about a 3. Whereas, I've been stung, on my arm or even my forehead hurts a whole lot less. And if you get stung in your lower leg, your calf or something like that, it's even less yet. So it all depends. I kind of, well, depending on where I get stung, I sort of say, well, that hurts a little bit more than what it really would an average sting. So I'll sort of downrate it a little bit. Or if I get stung in some place like my upper lip by, say, a wasp that I'm studying, and that really hurts, I'd say, well, that's kind of a 3, but I know because it stung my upper lip that it's a lot more than it should be. So I think it's still just a 2, nevertheless. So I can't really distinguish finally, between more levels than just 4.
Okay, fair enough. So this may seem like a question with an obvious answer, but why do insects sting humans?
Oh, they think we're threatening them. And that's the whole problem that people have with insects with, for example, running a lawnmower over a nice, Toronto lawn in the late summer and making everything all ready for our barbecue that we're going to have. And we run over a yellow jacket nest. Well, the yellow jacket's saying, oh my goodness, look at this horrible, vibrating, shaking, threatening, scary monster that's out here to eat me and kill all of us, kill all of my nest mates and our babies and, everything. So they're coming out trying to say, go away, leave us alone. They have no intention of, provoking us or stinging us. They just simply want you to, live and let live. You let me alone and I'll leave you alone. And so there aren't really any stinging insects that intentionally come and sting us with the possible exception of fire ants. Fire ants just really have a bad attitude. and fire ants, they're a little different from the rest. And I think one of the reasons they sting us is they see anything that's living, especially if it's meat, and we're sort of meat, as being potential dinner for them. So they want us for dinner rather than worrying about us wanting them for dinner. So that's the only one exception. But all the rest don't really want to sting us. They just, want to avoid trouble. And we're just clumsy bumbling around, doing things and not really noticing them. And so that's how we inadvertently, in their eyes, represent a real threat to them.
What is it about a sting that makes it so painful?
Oh boy. Yeah, stings are painful for a whole bunch of different reasons. And that's part of what makes it so interesting chemically, that it seems that each different group of stinging insects has almost independently evolved a system that works. By works, that I mean makes pain. So, for example, in a honeybee, they have melatonin, which is a little peptide. That's a small protein, in other words, that's very basic. In other words, it's more alkaline than it is acidic. And that causes a lot of pain by disrupting membranes, including, your nerve membranes. Nerves have little membranes and send electrical signals up to our brain. And you go and start disrupting those, and that hurts. But then wasps, as another example, they hurt just about as much. They have an entirely different kind of molecule. It's called a kinin, which the medical people know about because the bradykinin is an important compound in cardiac health and pain. It causes, heart pain and various other kinds of pain. Well, that's an independent way of making pain in us. And then we have bullet ants that have again, an entirely different system we call panerotoxin. And harvester ants have another one, which we call barbadolice. So anyway, as you can see, I'm dragging this on a while. Each of them has a separate chemistry, but they all have the same function. What they're trying to do is make us have pain. So we notice, hey, go away. This is not where I'm supposed to be. Get out of here. Skedaddle.
So how do some insects have a more painful sting than others? Is it just the chemical composition of the venom, or does it come down to who has more venom? How does that work?
The painfulness is a little bit of a combination of characters and factors. It chemically is certainly one of the most important ones. Many of the ones that really don't hurt very much don't have any known, compounds that are really painful. So they just inject a cocktail of various things that may be paralytic to their prey. Say they're catching caterpillars or flies, something of that sort. And they have compounds that will paralyze the nervous system of the caterpillar or the fly. But those compounds are pretty ineffective against us. We have a different nervous system than flies and caterpillars, which is a good thing for us. Maybe not for the caterpillar, but it is for us. So those tend to not hurt very much. The other ones I mentioned earlier all hurt us. We don't know whether they hurt caterpillars or flies because, well, how do you ask a caterpillar or fly if it's in pain? Pretty hard question to figure out. It's like you mentioned, the amount of material injected. You get a great big bullet ant, and it can inject a whole lot more venom than a little tiny, wasp or ant can. And so it's a combination of what the chemistry is and how much of it is injected.
Okay. How did you rate the most painful sting you've ever received, and which insect did it come from?
Yeah, when you get to the really painful stinging insects, those are the 3s and the 4s, which the good news is, except in a possible exception of extreme southern Alberta, you don't have any 3s and no 4s in Canada. But the U.S. has all kinds of 3s and some of the 4s. And basically what is going on there is it's a combination of intensity, like the tarantula hawk, which is a 4, that's the most painful in the U.S. It's just absolutely electrifying. It's just so excruciatingly intense. It just shuts you down. It's almost like sending nervous impulses through your brain that just inactivates anything else that's going on other than your ability to scream and feel the pain. And so that's based purely on intensity. And some of the others, like the bullet ant and the warrior wasp, which are also 4s, the only other 2 4s. The good news is there's only 3 4s. So, I guess that's something we can be grateful for. But they have a combination of extreme intensity, perhaps not as high on the immediate pain as the tarantula hawk, although when you're suffering that kind of pain, it's really hard to say, well, is this that much more than the other one or not? You're just sort of screaming in an agony. But all 3 of them are up there near the top. The tarantula hawk is a short-term pain, lasts 2 or 3 minutes, which is good. And the warrior wasp lasts about an hour, which is, less good. And the bullet ant will give you this excruciating, burning, just tearing pain that'll go on for 12 to 36 hours. Definitely not good. So it's a little bit of a combination of how intense it is and how long it lasts.
Oh, yeah. Why did the sting involve only in certain groups of insects, like the stinging insects that you study, and not in others?
That's an excellent question of why it was only the stinging insects in the order Hymenoptera and that evolved a sting that's like the kinds I'm talking about. And that's because the stinger was essentially evolved from their ancestor, was an egg-laying tube, an ovipositor. Only females, of course, lay eggs. And they were laying eggs in plants or in sawfly larvae, for example, that are burrowing deep in wood. And so they had this burrowing, boring kind of ovipositor that could insert itself and penetrate through materials to lay the egg in a nice, safe, wonderful place. And from that evolved the parasitic wasp, which then still used the egg and ovipositor as a stinger. In this case, they would insert it into something free-living like a caterpillar or a stink bug or, something of this sort. And they would then lay their eggs through that. And some of those had paralyzing venom so that they could inactivate their hosts for their eggs, while they're busy doing their work. And then those then evolved into what we call the aculeates. That's the true stingers. And they were the ones that now no longer lay eggs through the ovipositor. It's now a dedicated stinger. And the eggs come out of a different opening at the end of their stinger. Now is used just for delivering venom. And that then allowed them to evolve a whole different uses of the venom. They could evolve, for example, to be defensive, which is what I study. And no other insects have that same system. The stinging caterpillars, for example, have spicules or spines. They're kind of, you look at some caterpillars and they're real spiny. Some of those have venom in them, much like jellyfish in an analogous situation, where you break the spine breaks off in your skin, the tip, and injects the venom. So that's a whole different system. But yeah, only the kind that I study have a modified egg-laying apparatus.
Okay, so you're clearly fascinated with stinging insects. You've been studying them for a while now. What is it that drew you to them in the first place?
I kind of came into the back door in studying stinging insects. I'd always loved insects and biology and zoology, and I got much of my training in British Columbia, which is just a wonderful outdoors place, lots of fascinating biology to do. And I was training as a chemist, and I love chemistry. Chemistry is great fun. And so I decided, hey, I love chemistry, and I love biology. Isn't there some way we can combine the two so I can have double joys? And I discovered there was something called chemical ecology, which is, as the word would say, the chemistry of ecological life systems. Communication and defense is kind of part of communication. You're communicating to somebody else, leave me alone. And you do that by stinging. And I was studying the chemistry of harvester ants, which are a group of fairly good-sized ants down in the southern U.S. and the western North America. And I was trying to figure out what made them hurt so much. And I was studying the chemistry of that. So in the process of that, then I ended up realizing that, chemistry and the biology are really closely interrelated, and they're fascinating. So that's how I got on this long, wonderful trek that I've been enjoying ever since of studying stinging insects.
Oh, yeah. You've included 83 different insects in your sting pain index so far. Do you plan to continue adding more insects?
Well, not intentionally, going out of my way to, but I've added another one. We have a 84th one now, and that's a euglossine or orchid bee.
Oh.
And they're beautiful gems on wings, just spectacular. And you see those in Central America, Mexico, and South America, usually in the forest, particularly the rainforest. But they'll be in some deciduous dry forests too. And I was in Florida where one got inadvertently introduced, and I was working with a fellow who was studying them, and he had some, so I got stung by one of those, which was kind of interesting. So we got one more, but no, I'm not, making a major effort anymore to pretty much most of the answers I wanted. I've pretty much, gotten those answers, and I'm doing more different things now.
Okay, so you didn't actually actively seek out any stinging insects to include in your index. You just happened upon all of them by chance?
Oh, no. I actively sought out many of them because I would read the old time naturalists were fascinating reading. If you ever get bored, read some of them. There's some wonderful stories from Africa and from Central America and Amazonas and, Borneo, and Alfred Russel Wallace had some writings about, and Alexander von Humboldt had some writings about South America. And so I would read these and I would say, wow, look, they have reported stories about these amazing ants on the Amazonas River, or these amazing ants in southern Africa, or wasps that are in eastern Peru and western Brazil and these sorts of areas. So I would go to some of those areas to try to study these. So I was actually guided by some of the great naturalist experts that came before us.
Is there any particular insect species you know of that hasn't been included in your index, but you would either like to include in your index or avoid entirely?
Some of both. Some of the ones I'd like to include all of them, but I wouldn't like the process of having to include them. That's the downside of it. And there's some ants that live in Congo region, Central Africa, that rain out of trees and sting anybody, like a giraffe or a zebra or somebody that's coming along deciding to munch on the leaves of their tree. And Dan Jansen wrote about how fierce they were back in the 60s. And as far as I know, nobody's really followed up on those. And so those would be an interesting one to study. And then there's a whole batch of really wonderful ants in western Amazonas that I haven't actually, ants and wasps in particular, that I haven't gotten to study. The ones that I really would not look forward to getting stung by, but should be in the pain scale, are some of the giant hornets from Asia. And I never got stung by them. I was, so intimidated by them. I mean, these things are huge. They're 5 centimeters long, 2 inches. They're stocky, orange-headed, blocky, headed orange wasps on wings, and they will come eyeball to eyeball with you and snap their mandibles, snap, just really intimidating. You see this monster, almost bird-sized thing. You say, I don't think I want to get stung by this thing. So I've studied them. I studied some of their venom, but I've never actually been stung by them. So that's one that I have some trepidation of. My prediction is, for people who are braver than me or more foolish or both, is that my prediction is it'll be about a 3. It'll be like a yellow jacket, except a yellow jacket on steroids and growth hormone, a much bigger one.
Did you ever wonder about experiencing serious negative consequences other than pain from allowing yourself to get stung by an insect?
Oh, no, I was never worried about the insects. I was just worried about where I was. I was worried about, oh, my goodness, am I going to get scrub typhus in Africa? Am I going to get malaria? Am I going to get onchocerciasis or river blindness? The other things out there, the flies and the ticks and, the various things that can really do you in, or having an accident. Anything from a good friend and colleague of mine got in a fatal accident when he was doing field work in Jamaica, because he forgot that Jamaicans drive on the wrong side of the road compared to Americans and Canadians. And so, I think in some panic situation, he did a reflex and got in the other lane and hit something much bigger than him head on. Mm-hmm. So those are the kind of things I really worry about, is, kind of an accident, or, any time you go anywhere, you have to be, kind of cautious. And those worries concern me a lot more than the stinging insects ever did.
Oh, for sure. For any field scientist in another country where you're not used
exactly.
to. Yeah.
And, sometimes many of these societies have, a very poor population, and the population, resorts to sometimes saying, well, this is an opportunity to, find somebody that has some money or something and might want to rob him. And, well, I don't really want to get robbed, Losing the money wouldn't be the worst thing, but getting hit over the head is certainly something I'd worry about.
Oh, for sure. Have you been mugged before?
Not in field work.
Mm-hmm.
I have been. In fact, actually, we had a big conference in Paris. I shouldn't say this. The French are going to get mad at me. But one of the most distinguished senior scientists from Japan got his pocket picked in the French subway, and he lost all of his I think he lost all his money and his passport, all that sort of stuff. A real nuisance. And think of as the safest civilizations still have, their own sort of downside risks that you really have to worry about.
Well, yeah, no one's safe, especially if people can pick you out as a tourist.
Well, exactly. You look vulnerable, so you have to learn, try to look like you're confident, you know what you're doing, and you're familiar with the area, and just leave me alone, go find somebody else or go get a job, do something else besides bother me.
Or try to blend in if you can.
Exactly.
So do you think it's possible that an insect would be able to deliver enough venom in their sting to kill a human?
Not one insect, but many insects can. There have been quite a few cases, probably thousands. The records are very poor, but it would appear probably thousands due to massive honeybee stings, especially in places like Latin America, where as the Africanized bees were coming north, people weren't familiar with them. And so they'd end up, disturbing one in their backyard and getting, thousands and thousands of stings. The average person can survive maybe 1,000 stings. It depends a little bit on how big you are and, how good a health you're in, your age and those sorts of things. But you're getting 500 to 2,000 stings and it can get dangerous. And there's actually been a number of people outright envenomed. It's kind of like I draw the analogy. It's like a honeybee is 1/500th of a rattlesnake on wings. So as you can well imagine, a rattlesnake bite gives you a small chance of dying. 2 or 3 rattlesnake bites and you're probably not going to make it. And so if you multiply 500 stings by 2 or 3, you get 1,500. Here's a little bit of a math lesson. I know. But anyway, if you get, say, 1,500 stings, chances are you're going to die the same way as getting 3 rattlesnake bites. And so honeybees are the main culprit doing that. There have been a number in China as well of some of the giant hornets. They're so big and inject so much venom, which is quite toxic. And people can go into permanent kidney failure with as few as, a dozen, several dozen, maybe many more. And they go into kidney failure, which can kill them down the road. Or if you get, we don't really have numbers, but my guess would be several hundred stings could kill you outright much faster, perhaps direct killing rather than indirect of, destroying your kidneys. So it is possible, but it's extremely rare.
So do the hornets and the Africanized honeybees, do their colonies typically consist of thousands or many hundreds of individuals?
The giant hornets usually have, at least the ones in Japan, are usually somewhere between about 100 and 250, hornets. So they're fairly small colonies, but they're huge hornets. Mm-hmm. And that's, I think, why you don't have more incidents of people actually, dying of massive envenomations. There are some hornet colonies that get really big. There's a variety of different hornet species or different types of hornets in Asia. Some of them will have nests that will have maybe up to 1,000 or several thousand, hornets. And those would be more risky because although they're a little bit smaller than the giant hornets, they may be half the size. But if you can multiply rather than 100 of them coming out after you, 1,000 or so, you can kind of see where we're going. It gets dangerous, much more quickly. Honeybees are really bad because there's so many of them. An average colony of Africanized bees or feral bees in Africa and much of the world will be 15,000 to 30,000, individuals. And about half of those can go out and try to attack you. So as you can see, if you're having, say, 15,000 bees that are trying to sting you and you're not really protected or in an unsafe place, you could pretty quickly get a whole lot of stings and it gets dangerous fast.
Oh, yeah. We'll be back with more after this.
Science for the People is a weekly radio show and podcast that explores everyday life from a scientific perspective. We are a member of the Skeptic Network, a collection of blogs, podcasts, and video content focusing on science and critical thinking. To find out where Science for the People airs near you, or to listen to past episodes, check out our website at scienceforthepeople.ca. You'll also find links to support us at Patreon, to connect with us on Facebook and Twitter, and to subscribe to the podcast in iTunes. And now, back to the show.
Welcome back to Science for the People. I'm Anika Hazra, here with Dr. Justin Schmidt. So, you've gotten a lot of publicity because of your sting pain index. How do you think the public perceives you and your research on insects?
It's one of those things that I don't really worry too much about because I'm just, interested in doing the research, but I make the assumption that people think, oh, well, he's just kind of crazy or, this sort of thing. But I think the Ig Nobel committee, when I got my Ig Nobel Prize last year for this study, I think they really summarized it beautifully that the research that I do and all the other awardees first makes you laugh and then makes you think. And really, I think that's what I'm trying to do. And that's what I'm trying to do with my writings in the book, The Sting of the Wild, is trying to make you first entertained and laugh and then think and realize that hey, this is really cool. Insects are really fascinating and they have fascinating lives. And, oh, by the way, I don't really have to worry about them. I understand them. I know what to do. And so I can enjoy the beauty of them. And so I think it's something where you can turn, a craziness or a phobia into being positive and sort of something that's much more fun and lively.
You've been actually called the king of sting by various media outlets, and also the self-sacrificing man by Daily Mail regarding your endeavor to document pain caused by stinging insects. So what do you think of these kind of titles?
Oh, these are things that, I just call myself an entomologist or a biologist, and, other people have given them to me. And, it's fair enough. Journalists sometimes can get a better picture, looking from a different angle than when you're, doing it yourself. You're very close to, what you're doing. And sometimes, you're just too close to, really get the bigger picture. And so, that's okay. I think it's good to have a lot of different views and different people, giving their takes on, what I'm trying to do and bringing it to the public. That's the important thing.
Mm-hmm. So you were actually on the Jimmy Kimmel show recently. How was that experience?
So that was the experience, and Jimmy Kimmel was wonderful. He's a fascinating guy. I really enjoyed him. And it was just so cool that, I came out of the same door that Barack Obama did, a couple of weeks after me. So I thought, wow, such an amazing guy. He can just set you at ease. He has the ability to kind of almost knows what you're going to say before you say it. It's uncanny. And he makes it all fun and lively. It was just a wonderful experience for me.
And your pain index was also mentioned in the movie Ant-Man. What do you think about that?
Yeah, that was really cool. The Ant-Man movie, I'd never been to a Marvel movie. I'm too old and staid, That's for my kids, teenagers. They like these sort of fun things, but, I'm one of these old fossil types. And so I'd heard about the reviews. And I thought, oh, good grief, I'd better find out what this was. So my wife dragged us and the family off we put on these fancy goggles, to do the 3D and went to it. And that was just really cool. And I was just tickled pink because, first of all, I thought they did an excellent job of getting the biology of the ants right. I'm an entomologist, and, I always like it when people, get the biology and entomology right. And, some people complain and, nitpicked. Come on, get a life. They did a really good job of getting a lot of the basic biology, and it was just kind of it was a great movie, by the way. So I haven't seen too many of these superhero movies, but I thought that one was really enjoyable.
How do you think the public perceives entomologists, people who study insects in general?
I hope the public perceives all of us as being, good, fun-loving people who are out there learning to, not only love insects, but more importantly, put insects in perspective and use our love and talent to make life better for all of us as human beings. For example, we all like fruits and vegetables, and many of those are dependent on insect pollinators. Entomologists are trying to do is preserve the insects which are so essential for our quality of life. On the one hand, the pollinators, we want to keep them around. On the other hand, things like European corn borer and, various pests of crops, aphids and, whiteflies and things that are competing with us for food. We're in the front lines trying to control these things. So, hey, don't eat up all my corn that I have in a silo for the winter. I've got to have something to eat myself. And if you all get into there and eat it, then, I'm going to be hungry. And so entomologists are on the forefront of trying to protect our food supply. And we also would hope that the public realizes that when we get problems of outbreaks of infectious diseases, Ebola or Zika is now the current in vogue one that's, really rampaging the world, that entomologists are right there. And we're the people that are trying to not only learn about these, but protect, the population from these sort of terrible, risky, insects.
Mm-hmm. So do you have a specific message you try to get across to the public while you're doing interviews for the media?
My main message is that I'm trying to have people realize that nature and biology and science are really cool. It's cool stuff out there, and it's fun to do it. It's not just this staid thing where you're sitting with some sterile lab coat, in some lab, conjuring up at midnight, some brilliant, renovation or, whatever inspiration. But it's a really fun thing, and insects themselves are great fun. And insects can be a part of your life in a pleasant way. We love bird watching, for example. Make it insect watching. You can say, who's that on the flower? Is that a bee or is that a fly that's looking like a bee? Why is that fly looking like a bee? And, you can get all kinds of fascinating questions and wonderful things that you can do. Just make insects into a joy. Life should be fun. Life's too short to make it miserable. So we should, be enjoying life and nature and biology, and insects are a good part of what should make life fun.
Do you use a specific strategy to get people to appreciate stinging insects rather than fear and despise them?
I think the main thing is people learn from example, and if somebody's enthusiastic and positive and not showing fear, they'll often sort of realize, oh, this is really kind of fun. Let's, take a different view of it. On the other hand, people I write mainly, I think, for the adults, the parents of the young kids. I'm actually writing for the kids, but I have to write through the adults because the adults are the culprits. They're the ones that scream and imbue in their young kids this fear of insects by flapping at them and overreacting. Parents, stop that, darn it. Let the kids enjoy. Kids are natural born scientists. Let them get out there and watch that ant crawling around the backyard. Let them look at the spider on the flower. See if the spider's going to catch a fly that lands or a bee that lands. Let their curiosity go reign free, and don't go and squelch them. And so I'm trying to get across to parents that, you shouldn't imbue your biases on them. Obviously, if there's some risk, if they're messing around with the yellowjack call, no. That's what parents are supposed to do, is say, oh, we can look at them out through the window with binoculars, just like we look at the beautiful cardinal that's sitting in the top of the tree. We can watch them and see when they're active during the day and, what they're doing, but don't mess with them because, they can sting and be dangerous. But otherwise, don't just instill fear, which is, unnecessary and I think ruins the quality of life of all of us, parents and kids alike.
Mm-hmm. So as a scientist, your main responsibility is to conduct research. So why is it important to you to share your research and interest in stinging insects with the public?
Oh, I owe a lot of people a lot of debts, and they started when I remember I think I was like 4 or 5 years old, and we had a professor of botany in the neighborhood. And I found a 4-leaf clover. And I think maybe it was a 5-leaf clover. When you're 4 or 5, you can't remember those details very well. But anyway, I found this really cool clover. And I went down to see him, and, it's kind of, boring for a botanist or a scientist that, these things happen and you look around and you'll find them. But, he showed a real enthusiasm and excitement that I was excited. And, he just shared his excitement of life with me. And as I went through life, I had various people who, really contributed to my ability and future as a scientist, just inspiring me, mentoring me. And I feel that to a certain extent, all of us need to repay the debts that others, gave us when we were growing up and, becoming young scientists. And I think that's something that's very important for us to do, including myself. If I can inspire a few people to go out and do some great things, maybe it's not necessarily, probably not similar to what I'm doing, but if they can get interested in insects and then all of a sudden go on and find some cure for some disease that's transmitted by insects, I'd feel great if they got their first love of insects through studying stinging insects. So even though their contributions may be curing some horrible disease, that's what I want to do, is try to inspire people to, learn to love science and biology and do good things.
What advice would you give to other entomologists or just other scientists about communicating with the public about their research?
Oh, I think when you're communicating with the public, the first thing you have to do is be enthusiastic. And the second thing is, don't be too uptight. You want to, of course, not say anything really dumb, but don't, by your fear and all of that, or over exaggeration, instill fear. You want to just, and get out there and do it. It's not that hard to do. I'm kind of an introvert myself, and you see, I'm doing okay, or I hope I am. I'm having a good time chatting with, you and the audience. And I think it's really not that hard. You just have to kind of get over your fear and get out there and do it. People really are rooting for you when you're, speaking of these things. They're not out in most cases to, do you harm or anything of that sort.
Do you feel like there are enough entomologists who are actively engaged in public outreach?
Oh, I wish there were a lot more entomologists and scientists in general. It's one of these things that the future of science, and the future in particular of our species, humanity, is going to be based on scientific advances in many, many fields. And we really need to get much more of the scientific community out there, talking occasionally or more frequently about science, and instilling the greatest minds of our youth and such into going into science, and including entomology. And so I think it's really, we think of people like Carl Sagan, and how many, we probably will never know how many of the modern day astrophysicists and astronomers were inspired by somebody like Carl Sagan. And you could say the same thing from people going into biology and ecology by E.O. Wilson, Ed Wilson. How many people has he inspired? You don't know, but you certainly hope that people like this have done a really good job of pushing forward, society and science in general.
Okay, now I want to get into how you and your sting pain index might be perceived by other scientists actually within the scientific community. So your index is on a scale of 1 to 4 based on your own perception of pain that you experienced from various stings. And your description of the pain you felt from each sting is pretty subjective. And these descriptions, I would say, almost read like poetry. So do you think there could be a more objective way to measure pain?
I certainly wish that in the near future we'll get a better way to measure pain than a 0 to 4 pain scale that I've had to work on. Unfortunately, there's no real easy way to put electrodes into an animal or a person and record some impulse, some number. If you can get an absolute number, that's what's so beautiful about physics and chemistry and math, that you can compare because you have absolutes. And of course, pain is probably the least absolute, so we can't get numbers of that sort. I would hope that we'll get better systems in the future, but at the moment we're kind of stuck with the system that I've kind of developed. And one of the problems with having number systems is it's great scientifically. I can analyze things, and I can draw graphs and make correlations and make discoveries and test hypotheses. So it's very good scientifically. Unfortunately, it's not very good for communicating, on the human wavelengths. We communicate on emotional levels that have to do with song and dance and poetry and music and art and sculpture. We're a species that really communicate to the non-numerical methods, like I said, dance and poetry and such. And that was why I came up with the descriptions, that I wanted to kind of bring this to life. Another example might be if you have a car and you just call it car or whatever that is, you don't get any kind of real emotional attachment to the vehicle. But if you call it something like Esmeralda, we're going to take Esmeralda on a vacation now. Well, now you're connected to the car emotionally. And that's what I'm trying to do with the, writings that I have, the descriptions. They're not intended to be, literal. I mean, you can't compare those. There's no scientific way to compare those, but they're fun, and they're designed to, give you a human connection with the animals and the sting pain that they can deliver.
So you were actually catering to the general public when you were writing up these descriptions for your pain index. Yes,
the descriptions are definitely for, well, not just the general public, but the general public as well as the scientists. We're not all stodgy bunch of people either. We're like everybody else. We like fun. And so it was especially important that had something for everybody. Whereas, the numbers, that's just going to be the small percentage of scientists who care. Whereas I wanted to reach, everybody and, spread to everybody.
Do you know what other entomologists, your peers, think about your sting pain index?
Most of my peers actually love it. They think it's great fun. And I suppose there's some people that would say, oh, it's just kind of silly. But they usually don't tell me that. Maybe they're too nice. But I think most people realize that it's not meant to be a literal descriptions, but it's really meant to be, kind of a connection with our feelings and a connection with the insects themselves. And the scientific part is the numerical part. And people will debate on that. Is this thing a 2 or is this thing a 3? These sorts of things. If there isn't debate, oops, we got some trouble. And so, that's good that we have different people, saying, I haven't heard anybody wanting to skip saying, well, a 4, that's only a 2. They'll just say, well, is that a 4 or is that a 3? And, fair enough. That's what we do in science.
So you've mentioned already that you won the Ig Nobel Prize, specifically for physiology and entomology, along with Michael Smith in 2015. Now, the Ig Nobel Prize is different from a regular Nobel Prize. Can you explain how?
The difference is that the Ig Nobels are, as they state, something we've done research which often in the old days used to get. William Proxmire had something called the Golden Fleece Award, and that was basically for people that, in his silly opinion, were dubious science. It was just sensational and ridiculous and not worth doing. Well, it turned out most of the Golden Fleece awards that he gave out were actually for really good science. And that's because, as the Ig Nobels show, that they first make you laugh, and Proxmire stopped at the laughing phase, and he didn't progress to the next phase, which is then makes you think. And that's what the Ig Nobel is about. It's science that's good science, but it doesn't immediately strike you as good science. You have to think about it first, and then you realize, hey, there's something here, something that's good and worth pursuing.
And a lot of scientists who have won the Ig Nobel Prize have also won Nobel Prizes.
Could be. I'm not really sure just, how many that has been. But, we have all kinds of things which sound kind of silly until you think about them, and then you say, hey, that's really cool. So, yeah, it would be nice if we do have many of us that win, the real Nobel Prize for one thing, rather than getting 10 trillion Zimbabwe dollars as your prize. You get some money that will actually get you something in the grocery store.
Do you feel like you appreciate an Ig Nobel Prize more than you would an actual Nobel Prize?
Oh, I don't think you can compare them that way. That I think the real Nobel Prize gives you a lot more immediate fame and resources. There's a prize that goes with it, so you can expand your research, and you can get new collaborators, and pay salaries of young people to continue the research. which is a real plus of the real Nobel Prize. The Ig Nobel is perhaps more fun. So that's its real strength. That, we just have fun ceremonies. Yeah, I know we don't get to meet the king of Sweden or anything of that sort, but we get to meet golden girls in gold-colored paint and guys in silver paint, and we get to make fools out of ourselves and get to meet cute little 8 or 10-year-old girls with red pigtails and, all kinds of really fun things that we do. It was really quite a joy to, be part of that.
I was just going to say that I actually watched a little video clip of the ceremony from 2015 for the Ig Nobel Prize, and it definitely looks like a lot more fun.
It was, it wasn't, rather than us pontificating and giving a speech of how important everything was that we've done, in our life, we got 1 minute to say something, if you're lucky. and that's good enough. We actually got 5 minutes in the second. They had 2 venues, which wasn't recorded, in MIT where we had another one. We got actually 5 minutes in that case.
Dr. Schmidt, thank you so much.
Well, thank you for having me. It's been great fun.
I think you're a really great ambassador for insects and entomologists, and I really appreciate your time.
Well, thank you so much.
If you want to learn more about Justin Schmidt and his book, The Sting of the Wild, you can check out his links on our website at www.scienceforthepeople.ca. We'll be right back with one more thing after this.
Every week on Science for the People, we take the latest in scientific progress and relate it to people, our friends, our families, our communities, and our society. And we give researchers, authors, and journalists the time to talk in depth about what matters to them. If you love science but aren't satisfied with sound bites, join us again next week for Science for the People on your local radio station or anytime online at scienceforthepeople.ca.
Before we go, if you're the person who has everything or trying to find a gift for one of those people, we'd also like to give shout-outs to an assortment of science-related charities that will happily take your money. While we haven't exhaustively researched these organizations, we do think they deserve a mention for their fine work, but we also recommend you check them out before donating to make sure they match up with your values. You'll be able to find the full list with links to their websites in our show notes at scienceforthepeople.ca. If you'd like to help promote science awareness and understanding, you can give to the American Association for the Advancement of Science. They are an international nonprofit organization dedicated to advancing science around the world. They work to foster education and increase public engagement in science and technology for everyone, and to strengthen and diversify the science and technology workforce. In the UK, there's Sense About Science, which works in partnership with scientific bodies, research publishers, policymakers, the public, and the media to change public discussions about science. Their award-winning public campaigns share the tools of scientific thinking and scrutiny, and their International Voice of Young Science network engages hundreds of early career researchers in public debates about research and evidence. The Royal Institution of Australia is a national scientific non-profit organization with a mission to bring science to people and people to science. They aim to broaden the appreciation of science and technology as a part of the culture of Australia and to help develop inquiring minds that can appreciate the process, constraints, and potential of science. If we missed your favorite science charity, post a link in a description in the comments. Thanks for listening, and happy holidays. We'll see you next week on Science for the People. Science for the People is produced by Rochelle Saunders and edited by Ryan Bromsgrove. Helen Quivalon is our publishing liaison. We get research help from Josh Witten and consulting support from Desiree Schell. Our frequently seen guest hosts are Marion Kilgour, Anika Hazra, and Jessica Yaros. Our theme song is called Binary Consequence, and it was written and recorded by Fractal Pattern. Science for the People is entirely listener-supported. You can find us on Patreon, where you can support us with monthly donations in any amount, or you can send us a one-time donation in any amount via the donate page of our website. Science for the People is created in partnership with the Skepchick Network, a collection of blogs, podcasts, and video content focusing on the intersection of science, popular culture, politics, and social justice. You can find out more about Skepchick at skepchick.org. The show is hosted by science news writer Bethany Brookshire and me, Rochelle Saunders.